the first time, or rather the few times I first heard about artificial intelligence, all I could think about were these sci-fi movies and, like robots taking over the world, and all these things that we are fed in movies. And not only did I not realize that isn't exactly AI, it kind of is, but we are not yet there. We are not yet at the place where AI are real live robots which have thinking capacity like a human being. And it took me quite some time to learn more and understand more about AI. And so that's why I am so excited about our next speaker. Our next speaker is a lecturer and researcher at Wachemo University in Ethiopia, that is in the Department of Software Engineering. He is currently pursuing a PhD in computer science and engineering at NIT, which is in India, right? His key research areas are AI, machine learning, deep learning, smart grid, cybersecurity, and software engineering. Wow, guys. Here to demystify AI and talk about modern artificial intelligence is none other than Aschalew Turulo. Please help me welcome him to stage. Thank you so much, Aschalew. Have a go at it.
So hello everyone, and thank you, Clara, for the kind introduction. Okay, so my topic is modern day artificial intelligence. So we're gonna see modern artificial intelligence from the perspective or dimension of research, and from industry, from political perspective, from some. We will see some prediction what comes next. So when I come to artificial intelligence, as we know that it is a multidisciplinary field of science which incorporates science and engineering with other disciplines with the aim of creating intelligent machines. So basically, it's opposite of natural intelligence, which is demonstrated by humans and animals. So when I come to definition parts, and subfields of AI, so artificial intelligence has its own subfields. Like, of course, there is multidisciplinaries which supports artificial intelligence. You would like mathematics background, statistics background, and computer vision, biology. There are many disciplines which support artificial intelligence, including computer science. So when we come to its subfields, we will have like machine learning and reinforcement learning, deep learning, computer vision, natural language processing. So these are subfields under artificial intelligence. So when I come to the definition part of AI, so it's broad discipline with the goal of creating intelligent machines as opposed to natural intelligence that is demonstrated by humans and animals. So the ambition of the field to build machines that emulate then exceed the full range of human cognition. So so there is different kinds of definitions which was given by different researchers, different industry engineers. So also when I come to machine learning is it's nothing but a subset of AI that often uses statistical techniques to create a model which learns from data.
Actually, it's Elaine here. I think your slide, we're only seeing your first page. We weren't seeing your slides. And are you able to use your full screen so that it will be easier for us to follow you? Thank you.
Yes, I'm using full screen. Yes, how about now? When I come to machine learning is a subset of AI that often uses statistical techniques to build a model to perform which learns from the data without being explicitly programmed. So basically, as training a model using a learning algorithm that progressively improves model performance of specific some specific tasks. So when I come to reinforcement learning, this is also the part of machine learning concerned with developing software agendas that learns goal-oriented behavior by there is trial and error in an environment that provides rewards and penalties based on the action taken by software agendas. So there will be some policy towards that achieving the goal. So when I come to deep learning, of course, deep learning is an advancement over neural network. So it's also part of machine learning. So so it has several models, like we can see CNN, RNN, and transformers, and many more. So when I come to turning the next page, Clara, it's visible. It's visible on my next slide. Slide 3 is visible?
No, not yet. Not yet.
How about now?
We're still on definitions and subfields.
Oh, sorry. I'm turning. I don't know. How about now? Clara, how about now?
Not yet. We're still okay. Yeah. Now we're fine.
Okay. So again, we can see some basic terminologies. Algorithm, model. Algorithm is an ambiguous specification of how to solve a particular problem. There is model. We build a model using by training on data that output process known as this can be used to make prediction or classification or any other tasks. Supervised learning also, there is supervised learning, which a model attempts to learn, transform one kind of data into another kind of data using labeled training examples. This is the most common kind of machine learning algorithm. And secondly, we will have like unsupervised learning, which is a model attempt to learn data structure. Basically, it will learn like unlabeled data to produce some label or some outcome. So this could be an input to supervised learning also. So there is also transfer learning, research problem, machine learning that focuses on storing knowledge. We can use that knowledge to another related problems. And there is also natural language processing and computer vision. So we can see modern artificial intelligence from the perspective of researchers. Different researches are going on. So going on in academia, also in industry. So in 2022, in 2020, predicted that attention-based neural network move from natural language processing to computer vision tasks nowadays because of vision transformers. So, which is achieving best result over computer vision tasks, which was proposed by Google, and which is convolution-free transformer architecture. So we can see this architecture we can see the vision transformers architecture, or this block diagram from the paper of which was published in 2021. An image is worth 16 times 16 words transformer for image recognition at scale. It is a paper of Alex Lucas, and there is also another researchers which has done this research over this topic. So when I come to let us see this diagram. So which we will have some images which is going to be split into smaller patches, and then these smaller patches of images to feed to linear projected or flatted patches to then this going to be fed to transformer encoder. Then finally we will have classification, like is it going to something bird or ball or car, and then we can see the result of classification. So many more transformers performs well on computer vision tasks, including image segmentation, object detection, and others also. So I'm turning next slide, Clara. Okay, up to know any question, up to know any question, I can answer try to answer the question answer. Definitely, it's not clear.
I don't think there are any current question, Aschalew, so you can continue.
Okay, I'm turning next slide. It's coming or not?
Yeah, we can see it.
It's slide 6. So again, we will have some deep learning techniques. It's taking over computer vision tasks. So Facebook AI introduces here 1.3 billion parameter self-supervised model pre-trained on which was pre-trained on 1 billion Instagram images that achieves 84.2% top accuracy on imagery and suppressing all existing self-supervised models. So this is also from Facebook perspective. Transformer takes over the major AI applications, including audio and 3D point clouds. So beyond transformers, again, there is another kinds of algorithms, which is multi-layer perceptrons and convolutional neural networks, or CNN. They are also achieving. Previously, there were solving classification problems like image recognition, those all things. Nowadays, there is involvement of these two models. They are involving on natural language processing tasks, and problems, and computer vision tasks. So, so also there is remarkable progress in novel view sentences. There is one model neural, which is called neural redundancy fields, already achieves sort of results on viewing sentences. Like given multiple images of multiple views of an image, then this model use multi-layer perceptron to learn a representation of the image, and to render from those images, it renders the new views of new view of it. So it learns mapping from which would do like it learns a mapping from every pixel location and view direction to the color and density at that location. So also this is I don't know, I'm using cursor, but if it is visible or not, no. So input images are here. Then we can render new view of the image, and again it works. This performs previous works on datasets of both synthetic and real images. This, for example, translating or rotating objects without changing the background, and we can see the car objects, car images. The background is not changed, but the location of the car is rotating, but the background doesn't change. So this is also another remarkable progress over synthesis or real images. So large language models can generate functional proteins. Again, another AI research, which was done on large. The model was large language model can generate functional proteins that are unseen in nature. So proteins found in nature today are the product of evolution. So, but what if AI could generate artificial proteins with useful functionalities beyond what evolution has designed? This will work as a protein language model by predicting next amino acid for every for over 280 million protein sequences from thousands of protein families. Here, from the right side, we can see the first image that it is taking protein families as input, and then it's using protein language model to generate the protein sequences. This is also a remarkable progress in AI. So predicting and prioritizing novel drug combination, dosages, and timing for therapy for cancer patients also is using autoencoders. And also from the perspective of reinforcement learning researches. So there is a lot has done previously also, but also we can recall that AlphaGo 0, Alpha 0, and Mu 0. So AlphaGo was developed in 2016. So become the first program to master Go using neural network and tree search. So it was incorporating knowledge of human data, domain knowledge, and noun rules. So this was AlphaGo. So when we come to these are the older versions of this model. So AlphaGo 0 also, AlphaGo was working well for Go games, Go games only. So AlphaGo 0 works for Go. It incorporates only noun rules. So learns to play completely on its own without human knowledge. The Go was including human data, domain knowledge, and noun rules. So when I come to Alpha 0, so Alpha 0 was working perfectly for Go, chess, and shogi games. So by using single algorithm for all games. So it was incorporating noun rules. So it was also developed in 2018. So Mu 0 is the newest version, newest family of the DeepMinders. Newest zero family of from zero family again. This one is the latest one, which works perfectly and outperforms the remaining games. Sorry, the remaining models for Atari game. So it works well for Go, chess, shogi as Alpha 0, but also outperforms the previous models to Atari. Learns the rules of it masters the environment without unknown dynamics. It was developed in 2020. These are game to using reinforcement learning research. Okay, so this is Mu 0 is the latest one. So GAN have serious new adversary diffusion model. Again, okay, we may have afternoon. Is there any question? Not anything not clear?
None so far. I think you're good to go.
Okay. Yeah. Clary helping me on this. Okay.
Yes.
So another one is generative adversarial networks have series of new adversary, which is called diffusion models. These models help us to generate denoised images from noisy ones. Basically, we may have image status, the normal image status, then some noisy added to. If we want to revert it the normal image, then we may apply diffusion models. So at each step, these diffusion images will do like Gaussian whose mean and the covariance are parameterized using DNA, deep neural network. So diffusion models are no new, but recently improvements have made. It wasn't new, but new improvements have made them theoretically and practically perfect. So I'm on slide 14. Then DLE draws what you want, but you have to be sure what you are typing, what you are giving as input for a text prompt. If we give text image pairs, sorry, text prompt, text sentence. Okay, we want to draw an armature in the shape of an avocado. Then AI will give you the appropriate, or AI program will generate the proper images for the given text. This is also remarkable progress. I mean, when we are typing some text, then it will give the appropriate images for the text. This is we can see from this image. Then someone has typed text on text prompt an armature in the shape of an avocado. AI generated appropriate chairs which look like avocado. So this is the progress from OpenAI. So another one is Codex for Coders. This is also it is taking some user instructions in the form of text. Then it would give an appropriate text for the given, appropriate code for the given text. So we can see from this also. So we call from the diagram. So user is giving user instruction, then it will generate the appropriate code. So this is Codex for Coders. It's also from OpenAI. So there is also another framework for Python packages. So we know that, of course, this JAX also came from Google. It was introduced in late 2019. It's Python package that combined library for automatic differentiation and compiler for linear algebra to accelerate computations for machine learning researches. So this is also another form of package and another remarkable result from AI. So there is a bunch of things going on. Due to time, I didn't include each and everything here in the research part, and also I'm jumping to talent part. So of course, India and China see significant growth of AI talent, and India's AI research is most diverse now. So Brazil and India are hiring greater than 3 times more AI talent today than they were in 2017, matching and suppressing the hiring growth of Canada and the USA. So we can see clearly from the diagrams, AI is hiring trends over time as India, Brazil, and we can observe from these diagrams. And share of women authors of AI-related research papers also it's growing, especially in India. So again, there is much research work is going on in the field of AI from China. China, especially two universities, and Beidou and Alibaba, they are working great on AI researches. So there are also 2 Chinese universities that are competing now with world-class universities like Oxford, Cambridge, and Harvard. So when I come to industry perspective, industry also, there is a bunch of things are going on from drug discovery to vaccine search. So an AI first drug discovery companies of initial acquired for 1 billion. British AI first drug discovery company, Accenture, originated the world first 3 AI designed drug into phase 1 human testing. And this is now, it was 2021. Then this is now the largest biotech and the 3rd largest biopharm company in the UK, and next to GSK and AstraZeneca. The company has Further, 4 more drug candidates currently undergoing advanced profiling for submission of investigational new drug application, in addition to more than 25 active projects in total. This is also the remarkable progress of AI biotech and biopharm companies. So again, there is much going from real-time computer vision protects employees from workplace injuries, like from heat map incidents, employee not wearing PP and dangerous driving. This also, there is also another research is going in healthcare, like eye disease is petrol dish for medical AI development in the clinic. So expert level quantification of dry age related muscular generation developed by UK-based NHS team. So they have classified 2 research group. Then one is working this one, and they are working. One is working on this one, and then this one. So the stroke detection software helps 1 patient every 47 seconds in USA today. And also Chinese institution dominating research in smart cities. They won first and second place in all tasks of 2021 AICT challenge. Especially Beidou and Alibaba also, they are working great on this one. So when we come to Google perspective, Google beyond Gmail popular smart replay feature, the company AI-based grammar checker is now live across sheets, docs, and sliders. Sheets now also provides context-aware formula prediction and allow you to ask questions of your data in natural language. And Maps is receiving over 100 new AI features, including indoor navigation with augmented reality and new routing options that optimize for lower level consumption and carbon dioxide emission. Google also open source media pipe cross-platform toolkits for integrating fast inference computer vision functionalities. So they are releasing much things last 2 or 3 months. New things, new features. I didn't include in this slide because of time. Okay. Image supervision resolution. Again, zooming image from our mobile. So image super resolution enables us super zoom on consumer grade smartphones. Google supervision. There is one model which is from Google. Google super resolution via repeated refinement model iteratively refines noisy of 64 images into high quality 10. It resumes the high quality 1024 times 1024 image that outperforms guns model. So meanwhile, Chinese scientists time also showcased the 30 times super resolution zoom that mirrors computer vision with AI chips. AI makes so we can see from these images. So from the first images, it's 1 time and 10 time, 20 time, 30 time. How clear image it is. It starts from one part, then it's zooming up to 30%, and also there is no any blurring. The image is clearly showing the inside part of the image. So when we are zooming, so this is amazing. So when I come to, of course, that we have seen that AI is playing Go games. AI is involving in games. AI is involving in painting. AI is makes music. No, AI is inventing. Of course, there is one AI program which gets patent. AI system which gets it gets patent from South Africa. The system called Davos. It made better interlock food containers. So of course, most countries researchers are asking patent for AI systems. of course, USA has made the giving patent to AI system because of their law, I think. Yeah, it is saying natural person needs to take on all that they are invented. We are not giving to they have no written law that machine could get patent. But other countries also refusing, but Australia is on wait. South Africa is the first country to grant patent for AI system. So inventing in AI, American AI startups attract the most money, but now there is a revival from EU and the UK is also they are growing fast. Of course, that there are many areas that AI is involving. AI is not everywhere. Like every organization is rushing to use AI product directly or indirectly. They are trying to develop directly, indirectly. They are using AI. So the first when it's ranked that enterprise software is taking the first investment and also ranks also. So then next one is transportation, fintech, and healthcare and food, robotics. So when we come to software leads, while robotics is taking for AI, biotech, and defense are growing now. There is also much competition is going defense to strengthen their defense or military. So when I come to political perspective, of course, there is a lot of things are going. I tried to mention some. So we know that I think it was, if I'm wrong, correct me, it was 2020 or 2021. Google has fired the Dr. Tamif Gabru because of some internal research work. So there were some conflicts. It was creating some political issues. For AI governance, when we come to AI governance, DeepMind fails to gain independence from Google. They have mission to create artificial general intelligence by themselves. Then they want to work independently. But still, this is also creating another political issue. So, of course, EU is proposed AI Act or AI regulation in April 2021. So they have already working on it. AI Act regulation requirement in Europe also working. So when I come to also this creates some political issues, especially facial recognition systems. So some organization, some USA organization has gotten the permission to use facial recognition, especially for investigation of criminals. Agencies are reported using facial recognition for criminal investigation, and they used to verify person identity remotely because of COVID situation. And 6 agencies processed image of unrest and protesters following the days of George Floyd. It was in May 2021. So technologies used by 40 agencies to support criminal investigation were owned by non-federal agency, and only one agency tracked by their employees used the system. This also creates another problem because it creates the rise of concerns over potential misuse of facial recognition. So military there is also involvement in military. Israel uses AI-guided drone swarm in Gaza attacks. So they are also using weaponizing smart weapons. This all and a smart drone system. They are using AI techniques. So USA Force Research Lab tests autonomous skyborg, and they have used artificial intelligence to integrate full mission autonomy with low cost, attractable unmanned air vehicle technology to enable manned and unmanned team. So of course, now also American, USA, uh, England, and EU also they're investing. And also they are allocating much budgets to AI works. When I come to, I'm coming to end. So when I come to prediction, there is some prediction which was predicted by uh, researchers and engineers. So the first one was transformer. Of course, any I don't know how many of you is from this discipline. Transformer. The previous version of the elder version of transformers was used for natural language problems. So nowadays, no transformer is competing with CNN, convolutional neural networks, for image classification, image detection. So also it's much going, and when we come to transformers, and then when we come to semiconductors organization, and they are also investing, and DeepMind is major research breakthrough in physical science. JAX framework, of course, now we are adaptable to PyTorch and TensorFlow, these all things. What about JAX, which was developed by JAX framework, which was developed by, of course, currently it shows that 1% of it, 1% of it is used by researchers, but it's expected to be this number will increase. So there is also new research on artificial general intelligence focused research company is formed with significant backing and roadmap that's focused on sectoral vertically, example, developer tools and the life science. And when I come to conclusion, and if you have any question, I'm glad to accept and try to answer.
Thank you so much, Aschalew. I see that we actually do have a couple of questions. I don't know if we can actually unmute Erwin, because he seems to have a number of questions that he has asked in the chat. But I will just read them out in the meantime. Erwin asked, what is the difference between deep learning, machine learning, and RPA? He also asks again, does a framework exist to deploy AI in a farm to get the most out of it? This is especially in the bank industry. Aschalew?
Okay, yeah. I'm hearing you. And I'm trying to look the questions which was raised by participants. Okay, what's the difference between deep learning, machine learning, and what was RPA? Is he trying to say reinforcement learning? Or okay, anyways, do framework exists to deploy AI in the farm to get most of it is okay. Okay, thank you. Let me answer these two questions. Okay. Yes, there is a clear difference between machine learning and artificial intelligence. Basically, machine learning is using statistical and statistical techniques to develop models which could work for prediction, for recommendation system, for segmentation, and many tasks. When I come to artificial intelligence, we can use artificial intelligence for various tasks. For example, to create bots, we can use artificial intelligence. The other question is there any framework that we can deploy framework exists to deploy AI in farm to get, yes, there are a bunch of frameworks that we can use to work on agriculture also. But it's better. I mean, AI itself doesn't work like we have to integrate AI system with another kind of I don't know uh, for what kind of application he needs. For example, if he needs to detect disease from the plants, or he needs to monitor the soil quality, or so depend on the application that we have in hand, then we can use uh, tools. So we have to incorporate this technology with Internet of Things. We have, for example, to recognize that or to detect disease from the. Of course, we can develop mobile application, uh, then which would take the image of the plant and then can detect the disease from the image taken. And we can use some sensors to monitor the moisturity or moisture, the soil quality. We can deploy some sensor and then we can integrate with AI or machine learning techniques. Then we can use for the things that we want. And of course, that we can use TensorFlow, PyTorch, and many more frameworks. If he needs for developing intelligent agents or intelligent programs. Yeah, basically, we use AI to create intelligent agents, intelligent programs, or intelligent softwares. Okay, if it is not clear, then allow them and then we can discuss with them. You can allow unmute them and then Clary, you can unmute them and then we can discuss if it is not clear. Anyone who wants to some clarity, he can or she can raise hand.
Yeah, thank you so much, Aschalew. So many people in the chat are asking that you actually share the presentation. So if you're able to just maybe share it as a Google Drive link in the chat below, or you can just actually just share the file as it is.
Okay.
Mm-hmm. Yeah, you will.
Yeah,
you
I
will
can
let
share
me
definitely.
know
Definitely, I will
that
share.
yeah.
Yes. Yeah,
Yes.
definitely, I will share. I have
Then,
another. Okay.
yes,
Okay.
awesome. So to everyone asking about the presentation, yes, Aschalew will share it. We have another question, and that's from Jean, who's asking about predictions. So I want to know predictions in finance, bank, and account jobs. I'm not so sure what this question is alluding to. Jean, maybe you can further clarify. It's not so direct.
Allow him or her. Allow
Mhm.
him or her, then we can discuss.
Okay. So to the Q&A, Raymond is asking, any AI successful case studies within the Kenyan financial market that you can share? So maybe, Aschalew, since you're not Kenyan, maybe you can just give us about Ethiopian. Yeah.
Okay. There is no. I mean. So if something is there, if something is done there, so we can get it. That if it is publicly available, if it is not publicly, we cannot know like what's going on. So I didn't get any research paper or blogs which talks about a specific topic or in these countries. I mean, maybe I'm not quite sure.
Okay, thank you so much, Aschalew. And also just to answer Raymond in terms of the Kenyan financial market. So in terms of case studies, I would just say that what's happening in finance and AI is basically what we see on a day-to-day basis. That's things to do with credit scoring, things to do with algorithms that can be able to detect fraud when it's happening, especially with regard to bank accounts, transfer of money, We also have AI in trading, which has been mentioned quite a bit. That's algorithmic trading. And also, let me just add in maybe like the use of chatbots in finance, just to help with customer service and to help with all these things. That's just my view on Kenyan, because you have asked specifically for Kenyan. We can then move on. We do still have another question for you, Aschalew. And you're being asked why reinforcement learning approach is different from the deep learning and shallow learning approaches. Maybe you can just clarify on that.
Okay, thank you. That's a good question. We use reinforcement learning to create software agendas. Basically, an application area of reinforcement learning is to create games. That for that kind of applications, reinforcement learning is preferable. So we use reinforcement learning to develop software agendas, which will like to try and error. Then there will be some punishments if he lose, or if he gets some rewards. So this is an action that's taken to software agendas. There will be some policies towards achieving the goal. So when we come to deep learning is nowadays working well for natural language tasks or problems, or computer vision tasks. Okay, we can use CNN for computer vision tasks, and LSTM and transformers. So they are different. Yeah.
Okay. Thank you so much, Aschalew. Are there any other questions? Does anyone else have a question? If not, Aschalew, I do have a question for you. And my question is regarding computer vision. So you do research in computer vision and a bunch of other things in AI. I would just like to know, the major problem we have with most of AI is lack of data. So where exactly would you say would be the best place for someone starting out in computer vision to go and find actual data, that's image data? And if you have yourself interacted with this kind of data, have you ever reached a point where you have to manually label the images yourself? Yeah, just give us a data source. Give us tips and tricks on how we can get started as well researching in computer vision.
Hello. Hello. There is voice clarity. Clara, I didn't hear your voice clearly.
Hello, can you hear me now?
May you summarize the question?
Yes, I'm just asking, where do we get started with computer vision in terms of research? Where can we get data for image classification and for computer vision?
Okay. Thank you. So what kind of problem we are solving? If we are solving healthcare, for example, computer vision we can use for healthcare images. If we are using.
All right. I think we have temporarily lost Aschalew. But in the meantime, please continue asking any questions that you may have.
Can you hear me now?
Okay.
Can you hear me?
Yes, thank you. Yeah, now we can hear you.
Can you hear me now? Can you?
Yes.
Okay, thank you so much. Thank you so much. I was answering your question, but I didn't know that I wasn't audible. Okay.
Yes, please continue.
So if you are solving healthcare related issues, so for example, if you are working on GI tract images, which means gastrointestinal tracts, if you are using, to investigate GI tracts, we have to use endoscopy. Several kinds of endoscopy, the bronchoscopy, colonoscopy. So when we are using wireless capsule endoscopy. It generates images. If I want to work on those images, so I have to go to Kaggle. Kaggle also one source to get image status for this kinds of specific problem. And we can actually, Kaggle is not for this one. Also, we can use for several machine learning models. If we want to train machine learning models, we can use deep learning models. We can use Kaggle, and there is also John Hopkins and another kinds of universities website. There is openly public websites are there. We have to go. We have to go that on that public websites. But also there is also, if I'm solving Ethiopian problem, Ethiopian issue, so I have to use local data. Demographic issues also there. Okay, if I want to prediction in Ethiopia, I don't have to use another country data because there will be some differences and some factors which couldn't be fit for my case. So we have to know what kind of data we want. Are we going to solve African problem or African countries problem? We don't have to use Europeans countries data set. We have to use specific location data sets. So, but data sets are available online. We can go to solve or to train models. We can go online, no problem. But what kind of problem we are solving? What kind of issues we are solving? That's the major thing. So we can get data online. Of course, there is a scarcity of data. Some countries are building some. They are building huge data sets, central national level data sets. So some they are sharing, some they are not sharing. For example, when we come to Chinese case, they are not sharing any data. We cannot, even they are not using some platforms. So of course there will be some security issues or something. So so what kind of my conclusion is, so what kind of problem in your hand? So you have to go with your needs.
Okay. Thank you so much, Aschalew, for that. I really do appreciate your talk. Thank you for showing us all the cool stuff like the avocado chairs. That was quite interesting to see. I do hope everyone else learned a thing or two, whether you are new to AI or this is your first time interacting with it or you have had some experience with it. Please do drop some emojis and applause for Aschalew as well as we conclude this session. I have posted his LinkedIn. In the chat, so you are free to go and find him on LinkedIn. Aschalew, is there any other way people can contact you, or LinkedIn is just fine?
Yeah, actually, I prefer LinkedIn. I'm on. They can get me on LinkedIn. So
okay,
I'm happy to interact with them.
Aschalew, Claire, let me come in here. Aschalew, we need to see your face because I think your video is not on.
Oh,
so
okay.
please come on so that we can all see you and then we can applaud you and thank you for the excellent presentation.
Yeah, I faced problem of uploading my background. It's not working. There is no Adobe. I think I'm using older version.
Okay.
No problem at all. We can see you.
Okay, thank you so much.
Yes, thank you so much, Aschalew. And thank you so much for staying tuned for this session.